Hi and welcome back to the last section of Advanced Module Concepts. In the previous section, Compatibility and Code Migration to Java SE 9, we went through different techniques available in Java SE 9 alongside how to use the GDIPS tool. The Java Dependency Analysis tool is to help you migrate your current code base to the new Java SE 9 platform module system smoothly. In this section, we are going to take a look at more advanced concepts introduced in GBMS. First, we will go through the creation of a custom runtime images, which is customizable GREs, reliable for microservices containers, embedded systems, IoT, Docker images, and limited resources devices, using the new Java Link tool, the Java Linker, to create a smaller custom runtimes, and then use them to execute our applications. After that, we will look at how to create a services and service providers as a modules, the mechanism for creating loosely coupled objects. This will help you to create a loosely coupled system components and modules. This can make larger scale systems easier to develop and maintain. Finally, how to create a service provider module with provider method. This option can be preferable for scenarios where we want to have more control over how the service implementation is initiated. Are you ready for this? I'm very eager to this, so let's start. Now we move on to the first video of this section, G-Link tool, creating custom runtime images. In this video, we are going to take a look at what is the problem which led to creating such a new tool, G-Link command. What is the G-Link command exactly and where to use it, and how the JDK and GRE modularization will help us to create our reliable custom runtime images smoothly. After all of this, we will use the G-Link command to create a custom runtime image for our Hello World application we have developed earlier. But first, let's discuss the problems we have previously that led to create such a great tool. Usually, we run our program using the default GRE. But in case if you want to create your own GRE, then you can go with the G-Link concepts. But wait a moment here. Why we need to build our own GRE? Let's look at an example to make it clear. Suppose we have a simple Hello World application like this. If I want to run this small program on my system, I will need first to install the default GRE. After installing the default GRE, I can happily run my small Hello World application. The problem here is to execute this small Hello World application, we just require the following classes. Hello World, which is our application, string, system, object classes. Here these four classes will be enough to run my application. So what is the problem? The default GRE provided by Oracle contains around 4,300 plus predefined Java classes files. If I execute my Hello World application with the default GRE, then all the predefined classes files will be executed too. But if I only need from 3 to 4 classes files to execute my Hello World application, then why I need to maintain all the outer classes files? So the problem with the default GRE is that it executes all the predefined classes files whether you want or not. And also if you look into the default GRE size on the disk space, then you will find it's around 203 megabytes for executing my simple 1K byte of code. I have to maintain 203 megabytes of GRE on my machine. It's ridiculous. It's a complete waste of storage. So by using the default GRE, it means waste of memory and performance hit. We'll not be able to develop microservices or applications for limited resources devices effectively that contain a very little memory, not suitable for IoT devices. So, Java was not the best choice for microservices and IoT devices in terms of reliable configuration and scaled down systems. But that was only the problem through Java 8. Meanwhile, Java 9 comes with the G-Link. With the G-Link, we can create our own small GREs that contains only relevant class or classes that we want to have. There won't be a waste of memory and the performance will increase accordingly. G-Link is the Java News command line tool through which we can create our own customized GRE, and it allows us to link a set of only required modules to create runtime images, which is our own GREs. Now, let's see first what is the new G-Link command is. As I have said before, it's a new tool in JDK 9, is the G-Link command, the Java linker for creating custom runtime images. In a custom runtime, you can include just what's necessary for a given application or set of applications to execute. For example, if you are creating a runtime for devices that does not support GUIs, you can create a runtime without the corresponding modules that support Swing or JavaFX. So now, let's see how the GRE and GDK modularization helped us to create our custom runtime smoothly. With the modularization of the GRE, now GRE is a proper subset of the GDK. So if you run the following command Java with the option --list modules from within the bin folder of the GRE, the result contains only the GRE's 73 modules, rather than the full listing of the GDK's 95 modules. This number will change as Java evolves. You have to note that you can use the modularization of the Java Platform Module System to conveniently create custom runtimes for limited resources or small devices. Now, let's begin the fun part, how to create our GRE. Now, let's move to create our own customized runtime GRE with the required modules for our Hello World application we have created earlier. So, start your terminal and change your folder to Hello World module application by going to exercise files and finally navigate to Hello World application as I'm going to do here. Now, let's first list the folder structure of this project using the following command, which is tree command. And the output shows the folder structure. So now, my Hello World program is in the module named eg.com.taman.hello. And we can compile our module-based application in Java 9 by using the following command. Java C using the option --module source path, providing the source folder, which is source, and please put the output into mods folder, which is the compiled version of our module, and I would like to compile this module eg.com.taman.hello. If you hit enter, it should run successfully and show you the compiled version. It seems it's compiled successfully. After compiling successfully, a folder with a Hello World app.class file will be created for this application. So let's tree again to see the structure. Successfully we have mods, including the compiled version of our module application. If you run this module-based application using the default GRE, you can use the command Java, pointing to the module path using --module-path, or the short version, which is only -p. The module's compilation goes to mods folder, and please execute the following module and class eg.com.taman.hello, and our application resides in eg.com.taman.hello package under Hello World app class name. Hit enter. It's executed successfully and show Hello World to Java SE 9 platform module system. But as we discussed before, our Hello World program application requires only few classes, files, string, systems, and object classes. These classes files are part of the Java Lang package, and the Java Lang package is a part of java.base module. So if I want to run my Hello World program, only two modules are required. My module, which is eg.com.taman.hello, and the GDK module containing these required classes, which is java.base module. So with these two modules, we can create our own customized GRE to run this application. So now we can create our own GRE by using the glink command as the following. Let's clear first the terminal. I'm going to use glink command to create my custom runtimes. Don't worry about the options, I'm going to explain them. Pointing to the module path --. I'm going to use the short version p mods, which include my module, and Java base is inside the full GDK installation folder. I'm using environment variable Java home, which points to my GDK, and the java.base is under folder gmods, and I would like to add to this custom GRE my module dash dash add dash modules, which is eg.com.taman.hello, and put the customized GRE created under this folder dash dash output. Let's call it hello world GRE. Hit enter. If it's successful, there is no output and it returned to the terminal again. We have successfully created our own customized GRE folder. So let's tree our folder to see this. Here is our source, here is our compiled version for our module, and all of these parts and folders and files is part of our customized Hello World GRE. Let's clear this. Let's get back to the last command to explain the options. The command's options are as the follow. Dash dash module path, or -p for short, specifies one or more folders in which to locate the modules that will be included in the runtime. In this case, the GDK's gmods folder, which contains the modular jar file for all of the GDK modules, and my module included in mod folder. Dash dash add modules specify which modules to include in the runtime. In this case, just eg.com.taman.hello, and by default it will include the modules that it depends on, and in this case java.base. Dash dash output specifies the folder in which the runtime's content are placed. In this case, the folder Hello World GRE. This folder will be placed in the folder from which you execute the preceding command, unless you specify additional path information. If the folder already exists, command an error will be occur. You have to note that Java Home environment variable must refer to the GDK's installation folder in your system. After executing this command as we did previously, you will find there is a Hello World folder created, which is nothing but your customized GRE. Let's have a look about this. Here it is, and it's include the bin folder, just Java and key tool, and all the required modules included here. If you check the module size, GRE size, it's only about 36 megabytes or 37.1 megabytes instead of 302 megabytes at your hard disk. Let's follow a few steps to execute our program by using the customized GRE. Let's go to the customized GRE folder by navigating to them, cd hello world GRE. I would like to be inside the bin folder, and from here I would like to execute my module, so I'm going to use Java. Please execute the module eg.com.taman. Here's a mistake, it's point not comma dot taman.hello, and my main application that resides in package eg.com.taman.hello world app, and hit run. Ta-da! It's executed and prints Hello World to Java SE9 platform module system. Congratulations! By executing this command, you can happily run your Hello World application. Finally, let's check the modules included in our custom runtime we have just created by executing the following command as previously. Just Java dash dash list dash modules, hit enter. Again, it only shows two modules, which my module and Java base, which is my module depends on. That's all about G-Link. I hope you now have a clear picture of how to use it to make your own custom GREs. So far, we get introduced to the new G-Link command and why it's here. Then show you how the GRE and GDK modularization helped us to make it easy for creating a custom runtime images smoothly. And finally, how to create a custom runtime image for our Hello World application.